This video provides a description of the mean and range control charts and demonstrates how to create these control charts under the assumption that the process standard deviation is unknown. In this case, we have 20 samples of 5 steaks measured in weight at a butcher shop. The measurements are taken in grams. These samples will be used to determine whether the process of cutting the steaks is centered consistently and whether or not the variability in the process is consistent over time. So we're assuming that these samples are ordered in time and that order has been maintained in the data. The first thing we need to do to construct the mean chart is to calculate the sample averages or sample means. We simply would use the average formula in Excel and calculate this for the first sample. Notice that there are 5 points in each sample and that the number of samples is 20. This can simply be copied down. The next thing we need to do is calculate the range. When the process standard deviation is unknown, the range is used as a measure of variability in the process. The range is the maximum value in each sample minus the minimum value in each sample. Here we use the max formula in Excel and the min function in Excel. By copying this down, we calculate the range within each sample. Once the sample means or averages are calculated and the sample ranges are calculated, we'll calculate the average of the averages and the average of the sample ranges. We can think of the average of the sample means as the overall center of the process. Once this is done, we need to calculate the control limits for the mean control chart. The control limits are calculated based on the sample range, the average range, and a constant called A2. A2 is simply the number of sample ranges above and below the center of the process that we want to go to set the control limits. A2 is based on the sample size, and there's a chart on page 608 of the textbook that can be used to look up the proper A2 constant. In this case, the sample size is 5, so the A2 value is 0.577. The mean control chart will contain 4 series of data. The sample averages, the center line, the lower control limit, here abbreviated LCL, the upper control limit, here abbreviated UCL. The average is simply the sample mean. I'm only repeating this with a cell reference in order to get these 4 columns directly next to each other in the spreadsheet. This allows us to make a chart very easily. The center is the overall center of the process, which is the average of the sample means. We can just reference that from the average that we already calculated. And if I hit F4, the function key, one time, I'll put the dollar signs in the reference as an absolute reference, and then I can just copy this down. The reason I'm just copying the same number down on the chart is because it'll be very easy to graph this line. The lower control limit is the center minus A2 times the average range. The center minus A2, I hit the F4 function key to create an absolute reference, or you can type in dollar signs. And then I reference the sample, the average of the sample ranges. The formula for upper control limit is exactly the same, with the exception that we're going to add the quantity on the right hand side. So it's the center plus A2 times the average of the sample ranges. The average of the sample ranges is denoted by R bar in the textbook. Again, I'm just copying the same number down the column because this will make it very easy to create the control chart. Excel line charts make very good control charts. All we have to do is highlight the labels and the data in the 4 columns that we want to appear on the control chart. We will go to Insert, Line, and I usually like to select the first one at the top left. And the chart appears. I'm going to highlight the blue line, which is the sample means, the series that's fluctuating on the chart. Right click, change series chart type, and switch just that line to this type of series that has the markers. It makes the points a little bit easier to see, and if we don't have a large number of sample means, this can make the chart a little bit more useful. I often want to put the chart on its own tab, so I'll right click out in the white space in the chart, do Move Chart, and move it to a new sheet. So here we have the mean control chart. The first thing that we look for is to see if any points are outside the control limits. Those would specifically be samples where the process was not centered consistently, and we'd want to investigate the reasons behind the process not being centered consistently. Here we don't see any points outside the control limits. So we would say initially that the process is in control, and we don't see any special causes of extreme variation here, which is what we would want to detect with this control chart. We can also use what's called runs tests to detect other variation in the process that might be worth investigating. That's covered in the lecture for this week. Let's create the range chart. The range chart will have 4 columns: the range, the center, the lower control limit, the upper control limit. The range is simply the sample range that was calculated earlier. I'm simply repeating this so that it will make it very easy to create the Excel chart. The center is the average of the sample ranges, and I'll reference that with an absolute reference by either typing in the dollar signs or hitting F4. The lower and upper control limits for the range chart are based on two constants, D3 and D4. These are again in the table on page 608, and they are based on the sample size, which is 5 in this example. D3 is 0, D4 is 2.114. D3 is 0 for some small sample sizes, but it'll be non-zero if the sample size becomes large enough. The lower control limit is D3 times the center. The upper control limit is D4 times the center. We'll copy these down just to make them easy to put on the chart. Again, if we highlight the labels and then highlight the data for the 4 series that we want to appear on the control chart, it'll be very easy to create this chart in Excel. With the labels and data highlighted, insert, and then line, and select the one at the top left. Again, if the number of samples is fairly small, right-click on the line that's fluctuating, which in this case is the sample range. Right-click, change series chart type, and we can put the markers on the control chart. Move the chart to a separate tab. So again, we don't see any points outside the control limits. We would say that the variability in this process is consistent over time. One thing to notice is we haven't said anything about whether the variability is consistently too large or consistently too small. We only are observing that it's consistent. And it's very possible that by identifying other patterns that cause variation in the process, we might be able to reduce the variability in the process, effectively reducing the ranges and the control limits over time. Some of this other variation can be detected by the runs tests that are dealt with in the lecture for this week.